Numerical analysis is a whole big topic which you can take several courses on, and I'm sure as an engineer you have taken many courses on that, not many, but at least something related to the topic on that. And it's a whole complete topic which also has its theoretical backup for, but we use it as a tool to support our simulations. So let's look at the next slide, which tells us the intersections between these three bubbles. First, the theoretical and experiment bubble has this identification intersection, which also means system identification. So ID 就是ID 嘛，系统识别就是老师另外开了一门课。And let me explain this. If we know our theoretical model, if we have experiment measurement, we need to build a model from the experimental measurement. So there are some techniques and methods that we can use to build up the model, and that process is called system identification. And that combines theoretical analysis and the experiment data. Here, down on the bottom, you see a picture of the Hubble Space Telescope. This is probably one of the pictures that Dr. Zhuang has access to since he has been in NASA. And what does this picture have to do with system identification? For any structure, we would like to identify its frequencies and some other structural characteristics. And using some experiment tests on the object, we can obtain a model for the object. Okay, let's look at the intersection between experimental measurement and numerical analysis. So if we have experimental data, we have an identified model, right? Then we want to check our identified model to see whether it's accurate or not, whether we did a good identification or not. And the process is validation. And 就是我们有数据得出来的一个模型，那这个模型要去跟真实的数据做比对，这就是检验的一个过程。然后这就是要包含实验跟我们做那个，就是什么数值分析的一个的工具都要用到。And the intersection, okay, and you see sort of the most common kind of numerical simulation we see is the position or maybe the behavior plotted as a function of time. Any questions? Then the third intersection is the intersection between theoretical modeling and numerical analysis. And I sort of talked about this in the previous slide. If we have a model and we want to find the behavior from that model, we need to do some sort of simulation. And the figure on the bottom is sort of interesting. This is not a typical simulation as you see in this upper figure here. This is what we usually see for or use or actually do. This is also a kind of simulation. You can simulate the environment in space by environment that is very close to space because you want the least gravity effect. And that's in simulation. Next slide. Okay, so all the three bubbles combined, we get the subject of control. And so what we're focusing on in this course is mainly how we use the techniques from all three places and combine them together. You see figures of well-known physicists and astronomers and even maybe mathematicians. They all contribute to this field since they are all either theoretical or numerical. people who had great contribution in these areas. Okay, so that was a very general introduction to the topic itself. Let's look at the next slide. Again, we're looking at system identification. If for those who do not quite know what system identification is, we have another more detailed description here. First, let's look at this. Whoops. I'm going to try to use this electronic board. This is often seen, this kind of figure is often seen in control. And of course, it may be in different variations, but it will have the basic structure, especially this center figure, which we usually call the system or plant. Here we have something that looks like a satellite. The next important piece of this diagram is this piece. What is this part? Yes, the input. And this is the output. And when we do system identification, so I don't need to say any more about input and output, only that we know they're usually digital signals. But then with the input and output combined, so this and this, we do a process called identification. And with this process, we can construct a model which will not be exactly this model here.